Good morning, everyone, and thank you for joining me in my session. My name is Mohit. I am a chief consultant at Atea Nor. The session today that I'm going to be talking about is achieving DevSecOps with infrastructure as code and pipelines to making sure that infrastructure as code is more achievable, is more accessible to your consumers. We could preach all day that infrastructure as code and pipelines are the future, that the automation would make the business better. But if the consumers do not adapt the infrastructure as code, it basically becomes a useless exercise. True DevSecOps is only achievable when deployment and operations both abide to a predictable and a monitoring governance scheme. If the focus is in just creating a system that people will just not adapt to, then this exercise is futile. In today's session, I'll mostly focus on Azure Cloud and Bicep templates with the Azure pipelines, but the concept in its sense can be translated to other clouds and other pipeline languages. It's possible to do that. The blend of IT infrastructure, the pipelines, infrastructure as code plays a crucial role in DevSecOps methodology. And the reason why I say that is because IAC forms the basis of automation. Teams today work on pipelines, they deploy, they test, and they push to production on pipelines. But the only aspect of that whole process that still remains less automated is infrastructure. Most of the times, they depend on the IT team, which again introduces delays. Sometimes they have to learn a new infrastructure as code language, which again pulls them back because they have to learn something that they might just have to do once and also have to upskill for something that they might not even want to use. And that is where IT team comes in. This is where we can help them uh, take the ease off and make sure the adoption is better. Uh, of course, pipelines is also very important here because if we can give this code in their language, in the way, in the methodology that the developers use, then this becomes much more adoptable. Yeah. The goal is using infrastructure and automation in such that the DevSecOps practices such that the teams actually would want to collaborate with you, share responsibility, and in the background of all that, help you deploy the secure infrastructure that you always want. To start with this, to start with the exercise, I'm going to introduce a little bit about the infrastructure as code language that I'll be using. Instead of ARM templates, I'm going to be using Microsoft Azure Bicep templates. Biceps are no different than ARM. They actually work on the same engine. The difference is that because ARM templates used to be too big, sometimes spanning over multiple files for their parameters and such, it was not very user friendly. In all honesty, it was a little difficult to use, and that made the adoption a bit more difficult. Microsoft introduced Azure Bicep as an answer to that. Biceps are basically similar syntaxes but simpler. What happens is that when you create a bicep file, the bicep file eventually is compiled into ARM templates, which is again taken by the ARM API and deployed into Azure as a system. So essentially, you end up with ARM templates, yes, but the adoption part of it for an ISC developer, this is much more easier to understand. It has simpler syntaxes compared to the JSON syntaxes that were there. Bicep files are more easier to read and concise. The authoring experience is also very good. Instead of going through the whole bracket system, there are bicep extensions available for the short bit code that give you autocomplete, and it's much more easier for you to get over there with the full set of instructions to deploy a resource very fast. They're also modular, which is an important aspect that we will be focusing on. Bicep modules is what we're going to develop and distribute eventually so that people in the organization can actually use those modules and run with it. There's also an integration with Azure services. As many of you might know, that Bicep is Azure's inherent language. It doesn't work on any other cloud. So this is specifically for Bicep. Now, the thing is, when we will be deploying these modules and distributing these modules, what we'll end up with is that the operations team will be able to sit with security team to decide what kind of security aspects do we want for the resources. For example, HTTP or HTTPS is a very good example, very primitive, but still very relevant. So we want the traffic to always come through HTTPS, but we can't depend or put this responsibility on developers. So what we do is we create IAC templates that actually function in such a way that when they're deployed, they always make sure that the traffic is HTTPS. Deployment team would start adopting the mesh in their pipelines, deploy it, and the module versions that we'll be deploying will have version controls also. So this gives leverage to the IT team in such a way that in case we want to introduce new features, let's say new constraints or new security responsibilities on that resource, people, teams who are using the current version can still use it because that would still be present with the version control. And we'll go ahead and check that out. The version controls are stored in Azure DevOps repositories, but they could well over be on GitHub or any other version control that you use. And a very harsh truth is that this will eventually give you a leverage in removing permissions that do not go with compliance. Now, once we deploy the modules and consumers start using it, our developers start using it, all they'll need to have is their pipeline accessing the modules. Everything else can be removed from the permission set. Let's start with the Bicep templates. There is a very good training from Microsoft Learn, which gives you the fundamental and the intermediate and advanced Bicep instructions. What you have to focus for this training to, if you want to follow along, is the modular part of it. The modules are introduced in the Bicep fundamentals, which you have to go first, and then the I'm sorry about that. The Microsoft fundamentals, yeah, and the intermediate training. One of those, yeah. But the point here is that it's a very basic training, and you could get started with this very fast. Taking you to the two aspects of what we're going to do. First, we are going to produce the modules, which is the IT team. I'll put on a hat of the IT developer who's going to facilitate a secure infrastructure resource module. And then we'll jump into the role of a consumer who's actually going to use this module to go ahead and create the resource mesh that they want. Um, a very good example is a web service with a database, but it could be much more complicated than that. The point here is that the the nature of the modules would make it so easier that all they have to do is follow one specific command line, and that would create their infrastructure in its entirety in the exact same format. Doesn't matter which resource they are deploying to. Cool. Now, if you look at my screen, you will notice that there's a top hierarchy folder, and I've named it as producer just to highlight that we are creating something as an IT team. What I do is I basically arrange these resources into modules, and that's the reason why the repository name has a parent folder called modules, which has subfolders for each of the resource that I'm trying to deploy. Now, it's very easy to get into a situation where you want to deploy or create templates for every small thing so that all of those things can be deployed individually. For example, a virtual network and a virtual subnet. It is possible to deploy a virtual network once and deploy many other subnets after that. It's possible to do that. But do you want to do it? That's the case. In case this is a very crude example, but in case you have a service that has one part of it that could be deployed independently, but do you want to have that granularity in case that that specific part would not be deployed eventually. So these things, they have to be taken care of, and this thought process goes into that. In my case, I've taken basic decoupling such that um, I've not gone into much of detail and only made sure that the granularity is has a balance between the ease of use and and the security of the resource. So not too much customization and not too much granularity. The resource that is the easiest and the one that I'm going to focus on to explain how this thing works is a resource group. Now, if you notice, I've devised three files. The first one is metadata.json, which basically keeps the versioning of the module. So if you notice here, it has a major version and a minor version. And I'm reading this file eventually in the pipeline to put these version numbers when these modules are deployed to Azure Container Registry. Just a gestation file with a small text. You could modify it. I have a rule that every small changes, for example, and a small HTTP and HTTPS stuff, they usually minor changes. If there is a major change, let's say I'm introducing a service endpoint, then that makes it a major change. A private endpoint, a major change. A network implementation, a major change. Let's say I'm changing the naming convention of the whole thing, a major change. Yeah. We skip the pipeline for the moment, look at the actual resource group. Now, if you notice here, the extent of the file, it's around 130 lines. And what I'm doing is a lot of things here that's for the governance aspect of it. And some of those things are also constrained on what can the user provide as a value. Now, this template here can be deployed in itself and can also be exported as a module, which is what I'm going to do. We're going to first test this template and then export it to a module in a container registry. Now, if you notice here, most of this template is basically me defining a parameter, giving it the value, defining the constraint of the parameter, and a description. Now, the description is very important because when the consumers start using it, they will need to have this description. They will have to decide the values that they have to give. And this description will be invaluable then. The constraint helps you as an IT team. It gives you the power that these templates can only be used in certain ways. And if they are not being used there or the values are different, the error messages that come up are also very simplified because the most that can happen is that you provided a wrong value to X and Y. That's it. Because most of these templates, all these templates would be tested before they're actually exported to container instances. These small error messages that are confusing at times will not be confusing anymore. I go ahead and deploy and decide on some of those parameters. I go ahead and restrict those values, give a proper description. And the one thing that I do is I also create the naming convention here. One of the biggest points of contention in any governance meeting is that the naming conventions are not good enough. Sometimes they are giving too many values, sometimes they are random, every team uses their own. This is where these templates give you a leverage of getting a uniformity there. I am deciding the naming convention based on what my preferences are and Microsoft's recommendation are. The an identifier to make it unique, project name, the environment, let's say development, test, or production, an identifier for resource, the short name for the resource, and something like a purpose because it's a resource group. So this is my preference, but you could also change. Please remember that every resource has a naming convention constraint. For example, keyboard has one of the smallest, like 3 to 24 characters. It might need to be considered when you're deciding this. But the point is, as long as these components are decided in their self and have proper constraint, it's possible to get these things under naming convention. Now, just something that I want to mention, it's possible to put minimum and maximum length of each of the parameters also. And when they all combine, you would eventually get what you expect in the length. One of the other things that I'm a big fan of is tags. Very helpful in governance, very helpful in identifying resource, very helpful in deciding policies for the resource. I've decided a couple of tags that I always want, and they are fetched from the properties that are listed above. Now, I've given, if you've noticed, for most of them, I've not given the values. I've just decided what is allowed and the description. I can also give a default value, but I want the consumer, the developer, to give values depending on what they want to use it for. And that is eventually fed here. The same concept would happen to every other resource. Let's say log analytics workspace. The same thing would happen here too. And I'm kind of keeping this as a practice, as a constant practice to make sure this scenario translates to every resource. What differs is that some properties or details for that particular resource group did not have properties, but log analytics workspace does. And that's all that differs. And this is all from the documentation. The moment you go ahead and type bicep and log, let's say resource group, you would notice that the bicep resource templates are available here, and you could just copy and customize it on your template here. That's all that I've done. Adding a parameter and making it more defined. The third thing that is very important is to output a reference to it. Most resources would need a reference in an ID or a name form if they need a reference to another resource. Let's say a web application needs log analytics workspace or a storage account to be attached to it. That is when the the ID and the name come into picture when we get the output. And I'll show you how to do that too. The third file, which is very important, is the pipeline file. The pipeline file is the actual place where I'm going to go ahead and put it all together and deploy it, and then eventually publish it. It has a very basic pipeline structure. It has a trigger depending on which branch you're working with. I'm working on a master branch, so the master branch is the trigger in case something changes in the master branch on the following path, which is again modules, resource group, subfolder, and anything inside that. That's double star. So anything on the master branch in that path, if it changes, the pipeline is triggered again. You could of course trigger it manually too. Um, Defining certain variables which basically correspond to the some of the variables required for the pipeline and the others variables for the resource group template here. For example, I could define criticality here and go ahead and refer that afterwards when I actually give the template an input. What I've done here is I've given the input directly, which I'll show you in a minute. Criticality, the name and the value, that's all you deploy. But some of the values are given directly. We'll go through that. Now, this is very important for the structure wise. If you keep defining variables next to the actual operations, it becomes difficult to track. So I just keep them in a bunch here. Then I define a pool in which it's a machine where the actual pipeline would be running. This could be Ubuntu. This could have your own virtual machine, which I do in the consumer section. I have a couple of stages. First, I lint the code, which is a basic sanity check, and this section is available on Microsoft website also when you go ahead and create a pipeline through UI. The operation, the task that I use in pipeline to deploy a Bicep template is Azure Resource Manager template deployment 03. And it's pretty standard. You could just import the task from Azure DevOps. I'll show you in a minute how the virtual user interface works. But what basically is something to note here is that I override a couple of parameters depending on what values are needed. So I've not given any default values. That means override basically means initializing it. And everything is using a variable from above, makes it easier to edit on a single plane. This is the location of the file, also defined as a variable above, the file that it's going to execute. If you notice here, it's under modules, resource group, Azure resource group, Bicep, right? And it needs a connection. It needs a service connection or a connection to your Azure resources where it can actually deploy. We'll talk about this. But the connection name is basically Azure DevOps identifier for connection or permission to deploy on the subscription. And we'll see how we set up that permission too. After we've deployed the resource group, I go ahead and publish it. And the publish task basically checks if the previous task for deployment is successful, which is a sanity check. If it's not, then that means the template was not successful. It has to be worked before it is published for consumers to work on. Again, to reduce the amount of errors, the variety of errors for them. This publish task takes the version number from the file that we've deployed. This is a standard script. You could probably copy it. And then it goes ahead and uses az bicep publish, targets a container registry with the module name and the module version. Module name is what we defined as a variable here, module name, and the version is generated through this script here. This is something that goes ahead and exports the JSON file, breaks it into hierarchical structure, copies the major and minor version and supplies it here. That's how the version module is made. And then it goes ahead and creates the file for the resource group Bicep, compiles it, and saves it into just container instances. We'll see that in a minute. Let me introduce you to the container instance. This is a standard container registry. And what happens after the published state is basically repositories being added here. So a resource group is added and the version number is major, minor, and the run date. And on that date, how many times has it been run? Let's go ahead and try to run it. I'm going to just change something and put it to Git. Remove the space, put it to Git, and publish it. Giving it a random commit. And we go to the project here. If you notice, I have two projects, one for consumer and the other for producer. So I'm going to go for producer because that is where the repository for this code actually lies. So the modules, resource group, they lie here. And if you go here, the pipeline that is for resource group is executing. Now, if you want to go ahead and create your own pipeline, the pipeline file can directly be imported through new pipeline from the same repository. You give the repository name and choose an existing YAML file and select the file that you want to introduce as a module. For me, I selected resource group and approved it, and that's how I got a pipeline that's called demo ISC resource group. Just a word of caution, it's not named correctly when it's done, so you have to rename it. Just go here and rename it. I'll see how to import the pipeline in a minute when we deal with the consumers also. While this is happening, you will see that it works on three stages that we've defined: lint, test deployment, and then publish. While this is happening, let me take you behind the scenes on how I've set up permissions. Service connection, establish service connection, and this is something that would pop up. So I've selected it on the whole subscription level because it has to go ahead and work on publishing the module at the end on one particular resource. So I've limited the scope to only the resource group that has that container registry. And that, when you save it, it saves the permission, and you could just use this name as the service connection here, like I have done for this. So for publishing, it uses service connection name 1. For deployment, it uses service connection name 2. And that's, again, the same thing here. Because I had to deploy a resource group, I could not limit it to just resource group, so I've left the scope to subscription level. Now, when we deploy, after the deployment is done, eventually it will give us a new version of resource group. Let's go back to the container registry, refresh it, and there we have a 4. It is advised to not deploy too many versions, publish only when you actually have something to offer, not every small deployment, because this tends to increase in numbers very soon. So that's the part where we deal with as a producer. But how is it beneficial to the consumer? On the consumer side, I'm going to switch the project to the consumer side. We don't have a pipeline yet, so we're going to create it from scratch. I've created a folder in the project, and in the folder, I have created again one sample pipeline. It's again the same structure. We have the trigger, the path, the pool. This is a virtual machine that I've created as a pool there, and that's the reason why this looks a little bit different. It's not run on Azure virtual machine, but on the custom virtual machine that I've deployed, and hence the name. Again, I've deployed variables depending on what resources I want to deploy. Let's say I want to change something on the resource or the sequence and stuff. And all the variables are listed under the comments, so it's easier for us to manipulate it on the same place. Again, we start with the linting, with the .NET, sorry, and then we go ahead and start to use the template itself. Now, this is where I'll stop the pipeline and we go to the resource template on how we're using it. Now, if you see here, this is the template that's actually creating a resource group for the consumers. Most of this is again parameter declaration for whatever values this template needs. But the crust of it is how do they go ahead and get these templates to be used. If you notice here, it starts with a keyword module. This module is used instead of resource. If you notice here, when we were deploying actual Bicep templates, the keyword was resource, but in this case, it's just module. The second parameter, the second character here, the word here is basically an identifier for the module. So just to make it unique in the parameter, so you could refer it by name. The third one is a keyword br and then the location of the template. The template is on a container registry, and this is what the container registry is called. If you go here, you could get the name from here. That's the container registry. And then we go one step in, the name, and then the version. And that's what it's done. The name, and then the version. Now, the magic of all the stuff that we did before, of description and definition, comes into practice here. Your target audience doesn't have to actually remember what values do they have to give. We do an equals to, and we give it a space, and we get a drop down button that says required properties, and this gives whatever values they are expected to provide in a nutshell as a prompt. They don't have to remember what all properties do, what indentation it has to be. Everything is predefined. Now, this doesn't end here. In case they're still confused about what values to give, it's possible to render our description that we gave in the beginning on the templates. That serves as an output here. So, for example, the location, the documentation that we did in the investment that we did in the parent templates serves as an output here. It tells you that the only accepted values are these, and the values actually refer to these regions. The same thing happens to everything else because we've already defined it in a very clear way. The criticality has these values, and why, what does criticality actually mean? You could give more information depending on your case study, but the point here is that the templates in itself function in a way that they're self-sufficient. They don't need explanation. So the learning curve is essentially flat now. And this is same for any resource that you deploy. They could have more parameters, they could have less parameters, but the essential mechanism, the display, the learning curve essentially is always going to be the same. The same goes for project code and stuff like that. If you notice, everything is defined hard coded, so there's no scope of having any problem. Also, if you notice, I've given my contact information. So, in case there's still confusion, you could have your IT team's mailbox here and people could reach out to improve. There's always a scope to do that. Instead of giving values directly, I've given them as variables. Now, these variables have been defined in a special way here because I'm not initializing them in the Bicep template. You could do that, but I have a practice of working with developers. Developers sometimes prefer to provide values on runtime with variables, and that's why I've not provided them here. I've defined variables that mimic the values, define the type of these values that are, and then I've used the pipeline to go ahead and define values for all of them. Let's, for example, take classification. I've defined it as a string, and the classification variable is ultimately being plugged to the resource here. And on the pipeline, the classification variable is defined under variables. And this is the reason why this is important is because all you have to do is change it in one place and everything else just remains the same. And Bicep is an incremental deployment. That means you could deploy it multiple times. If it's the same resource, it doesn't do anything. It just leaves it as it is. Now we take a look at the template deployment, the actual deployment. The deployment again uses the same resource template task that was used for Bicep, but this time the Bicep file doesn't actually have Bicep code. It has a module code that is very easy to adapt with just an equals to get you get all the information there. We give some of the values as hard coded, some of the values as variables. Like for example, the command file, the name of the Bicep file. In the previous producer, we were doing it as a variable, but here we're giving it as direct value. Whichever way is possible to make it easier, it's possible to do it there. We give overriding parameters, which basically means we're initializing it because there was no default value for them. We could give deployment names also. And for example, here, I'm not just trying to deploy a resource group. I'm also trying to deploy other resources also. For example, you will see Key Vault, NSG, VNet, public IP, Azure App Services plans, and all of that. So I've defined variables similar to the resource group. I've defined variables for them, created modules, imported modules, and provided values. The same variables. And if you notice, all the resources, they look same. They have the same structure, exact same definition, the kind of definition. It makes the learning curve flat. The essential thing that I want you to notice is that these modules can be each referred to each other. For example, the virtual network has to be present for the subnet to be created. And that's why when subnet is defined here, we can define a depends on situation like in any other programming language just to change these things. Very flat learning curve. And in that, the identifier is referred, and when the execution actually happens, the identifier is released as this code here, which is again released as the ARM code while compiling. And so it all happens in chain one after the other. The same thing happens for every other deployment. And if you notice, all of those are different resources, but they're deployed in an exact same way with exact same type of code. Makes the learning curve super flat. Bicep was making deployment very easy from the ARM templates, but the modules make it further more adaptable, further more adoptable for the developers also. And the same thing is repeated for everything else. And in the pipeline file, we go ahead and import these variables as override parameters by giving them variable values. One thing that's different here is that we've used the outputs also. Now, the resource group in itself was outputting the ID and the name, if you notice. We were outputting the resource group ID and resource group name. And that's what I've used here. While deploying the module, I've asked it to output the resource group name. And the output is assigned to another variable, which is, of course, the output. What happens is that when the output is given, it's stored in this variable, and we have to use dot operator to just extract it. And this script is a fixed script and is given in Microsoft documentation for Bicep, also Bicep modules in the exercise. Once that is done, the value is stored in a runtime variable called resource group scope name, which is again provided to a value. You have to notice this could be hard coded too. Absolutely can be. But my templates are generating names on runtime depending on the given values. So I'm using the output as a runtime variable to get the values. But in case your names are predefined, it's possible to define an hard code here too. Now, that being said, we're going to go ahead and now import this template on the pipeline. Now, yeah, so we're going to go ahead and go to pipelines, go to Azure repository, our repository existing, and we're going to deploy Azure back to school pipeline, the YAML file. And before we run it, I'm going to show you the assistant that you could use. And in this assistant, this is the task. I'm going to go to the end just to keep my code safe. All you have to do is select this, provide the service connections that we have, select one. If you want a subscription to be used, use that. All the star asterisk variables have to be done. Creating and updating resource group is what I'm going to do incremental. I do not want to destroy resources with this. If you want to select a resource group, you do that. If you do not want to, do not do that, depending on your scope. But here you have to give us a resource group because that's one of the constraints of the template. It needs a dummy resource group. And that could be anyone. That could be any one of them. But the thing is, it needs a dummy variable. This is sort of not relevant because you could create your own resource groups, like I am doing that for my resource. But this resource group here is just a dummy resource group that it needs for its operations. It's something they should improve on because it's no longer used if you do not want to use it. If you want to create your own resource group like I am doing and developing the name on runtime, it's not possible to do it here then. Select the name, location, I'm selecting a random location, linked template, give the template location like I've given in the template here, the location. Mm, the location of the bicep template. Oh, we hard coded that, didn't we? Yes, so this here goes into this template, and then you could give a template parameter file. And if you want to go ahead and give a deployment name and deployment output, which I have done to get the output of the resource group that's actually deployed. So this is this here. You do that, and then you add, you get the exact same task here. It's possible to create it through UI too. Now I'm going to go ahead and run it. You will notice that the name of the pipeline is the name of the repository directly, which I don't want. I want to have it a proper name so that I can identify. And there you go. Yeah. Now you'll notice certain resource groups would be deployed here. Right now we have these. When the pipeline actually deploys, it's going to go ahead and ask me for permissions because I've defined a service connection. I've input those service connections also, but I've not given the permissions. I haven't checked boxed the option that says give permission to all the pipelines, which is a no go because you should only give permission to the pipelines you want to use. Once this is done, we will eventually have a lot of resources available here. The first one is deployed here. And so the resource group is going through, and eventually it will deploy a lot of resources on this. You wait for a second. Well, after 5 minutes, the deployment is now complete. If we look at the resource groups now, we have more of them, and you will see couple of resources have landed up with the naming convention that we wanted. If we, let's say, go in them and check if the tags and everything are available, yes they are. We've given the configuration. I've defined Linux there, so the Linux configuration is available. um, and a couple of things like traffic. I could check another resource. Not sure if I defined, yeah, so not enabled from all the network. It's only enabled from select networks, and you could go ahead and give your IP also. I usually the default option is that it's enabled from all the network, which is not here. So if you see here, you could enable cyber security of your resources from the get-go, even before the resources are deployed. You have defined a standard, and that would go through a long way. Now, this seems like a tedious exercise to start with, but eventually, when you've started it and the consumers start adopting it, it becomes a fun activity and eventually a lot useful to the overall picture of DevSecOps. If you want to learn more, please start by reading about Microsoft Bicep. I've written a couple of articles about whatever I've discussed. The first article is called Achieving DevOps, Part 4.2. There's a 4.1 also, which is prelude to all of this. So, a general description of how these things happen. And there's Part 2 about the consumer part of it. How do consumers work and what do you need to develop that? I, as I mentioned, there's a Bicep add-on to the Visual Studio also that helps you work with that. All of what I discussed is available here. The code for the repository is available under GitHub under my repository, Bicep IAC Producer Demo and Bicep IAC Consumer Demo. These links will be provided to you along with the talk. Please go ahead and utilize them and let me know if I can help you out on this. Please reach out if and I'm open for communication. Well, and with that I conclude my talk. Thank you everyone, and you all have a lovely day ahead of you.